Hi, welcome to STR8CHEM. My name is Nurfazilah and today I would like to teach you about thermochemistry. Without further ado, let's hop on the questions. Here we have the questions of a bomb calorimeter. First thing first, it is important for you to list out all the information given in the questions. So here it said, a bomb calorimeter contains 780 grams of water. An amount of 2.34 grams of benzoic acid is burned in the calorimeter, and this causes the temperature to increase from 25.6 degrees Celsius to 36.7 degrees Celsius. So this is all the information given, and I would like to collect it in one place so that you get easier to look at it. So yeah, this is the list of informations I have collected from the questions so that we will be easier to answer the questions. Alright, let's move on to the part 1 questions, which is it asks to calculate the energy released in kilojoule if the heat capacity of the empty calorimeter is 870 joule per degree Celsius. So here it gives heat capacity which is of the empty calorimeter, which is 870 joule per degree Celsius. So this is one of the info too, so why not we put it in the list of informations here at the site. So I'm gonna put it here. Alright, and then the question wants energy release in kJ. Energy release we know is Q, right? And then here I will show you 5 possible Q absorb formula that we will possibly use in the questions. So here I have highlighted the formula number 1, 2 and 3 because these are the formula that we commonly use. Right, so in order to answer these questions, we must look first at what the questions have given so that we can choose what kind of formula, which one of this formula that we need to use to answer it. Okay, first here we know that the questions give the mass of the water, mass of the benzoic acid, and the temperature changes it gives here. So, before I forgot, since the questions have mentioned about water, so we know that the specific heat capacity of water is constant, which is, okay, I'll put it over here. C is constant, which is, this is little c, which is 4.186. This is constant for water. So, let's just put these little informations over here too, so that you won't get confused. So it's a little c, 4.186. All right. So I think we have all what the question gives. So from here we're going to use the formula. The formula number 3. All right, so the formula number 3, C plus C. All right, so go back to list of informations. So basically or simply we just need to substitute all the value into the formula. Right, let me make it quick. Since the C here referred to the specific heat capacity of water, so the mass, we need to use the mass of the water as well. So the heat capacity 4.186, the temperature change is 11.1 plus given heat capacity, which is this one, and temperature change. So here we calculate it and we get 45.87 kilojoule. So that is That is the answer. Alright, so without wasting any time, let's go to let's go to the part 2. The questions in part 2, it asks to calculate the heat evolved per mole of benzoic acid. So here, heat evolved is referring to the heat combustions of benzoic acid as it is being burned. So I'm gonna show you. This is the formula to find the heat combustions or heat evolved. I'm gonna put this heat combustion. So this is the formula that we're gonna use to answer these questions. This is the formula. Right, so alright, here we need to find the heat combustions, right? So Q here is referring to heat, and N down here is referring to mole of solution, which is here it wants the solutions of benzoic acid. So Q is already given. We already figured out Q from the first part, which is 45.85 kilojoule. So the only thing that we need to find now is the mole of benzoic acid. So since the questions already give the since in our list of informations the questions already give the mass of benzoic acid, and we can see in the questions it gives the molecular formula, and the molecular formula over here we can use as molar mass. We can use to find molar mass, right? Alright, so let's just recall a Mamonova tree that we have been taught. But here I have a Mamonova pyramid. So from here we're going to use this pyramid to find the mole of benzoic acid, because it already gives mass and we can find the molar mass from the molecular formula. So in order to find mole, we need to divide mass and molar mass. Alright, so I'm gonna put it here, and equals to mass over molar mass, right? So back to our list of information here. So the mass of the benzoic acid is 2.34 gram, and the molar mass we get from here is 122. Is it? Wait, I need to calculate first. Is it right? Alright, so we're gonna get N equals to 0.01908 mole of benzoic acid. Alright, so we already have the N and we already have the Q. All we need is to substitute all the values here. Alright, I'm gonna write it back here. Combustions equals to Q, which is 45.85, over the mole, which is 0.01918. So we're gonna get here 2391, sorry, 91 kg per mole, since this unit is kg and this one is mole. All right, And that is the answer for part 2 also. And I think that's all for today. Thank you for lending your ears. Don't forget to subscribe to this channel, hit that like button, and share to fellow students. Thank you very much.